All right, welcome to the video for lesson number 12, the first video on modeling sine functions. So for this lesson, we learned how to take a word problem, decipher some of the pieces of it to determine some of the parameters to be able to create a sine or cosine curve to model something, a situation that's sinusoidal in nature. So in looking at this first question, it tells us in the classic novel Don Quixote, the title character famously battles a windmill. In this problem, we will model what happens to Don Quixote's battles of a windmill and the windmill wins. Suppose the center of the windmill is 20 feet above the ground. We can see that in our picture here. And the sails are 15 feet long. So each sail is 15 feet long. So essentially when this sail is at the base, it's going to become 5 feet off the ground. And when the sail is at the top, or the actual maximum peak, it's going to wind up being 35 feet off the ground. It says the sails are turning at a rate of 1 counterclockwise rotation every 60 seconds. So that right away, that's important. That's giving us our period. So we know the minimum height, we know the maximum height, we know the period. So we can kind of go through and determine a lot of information just from that piece of the puzzle. So the first question says, explain why a sinusoidal function could be used to model Don Quixote's height above the ground as a function of time. Well, since Don Quixote, which you could kind of see him here hanging on to that windmill in the top right corner, is moving around in a circular pattern, we know that that's going to wind up being a sinusoidal function, right? So we can say his path is circular. The next part of the question says, sketch a graph of Don Quixote's height above the ground. Let t equals 0 correspond to the time when he's closest to the ground. So that means we're starting at 5. So if we just make a sketch here, so since the lowest value that we have is 5 and the largest value that we have is 35, I know my y values are going to have a range from 5 to 35. We then need to figure out, well, what's halfway between 5 and 35? So if we go up 20, we'd be at 25. That doesn't make sense. So we could try a different number like 15 or 10, but 15 does work. So essentially what you could do to find this amplitude is subtract the minimum and maximum and divide by 2. So if we go up 15, we'd be at 20, and that would be our halfway point. So it says that it takes him 60 seconds to complete one full cycle, so I know this is going to go out to 60. Halfway would be 30, and then we have our quarter turns, which would be 15 and 16 seconds, respectively. So if I'm starting at 5 feet, since it says he wants us to start from the minimum value, after a quarter turn, it's going to come up to 20. After a half turn, we'd be at 30. After 3/4 of a turn, we'd be back at 45. And then after a full turn, we'd be back at 5. So here's his path sinusoidally through. So it says, what is the amplitude, period, and midline of the graph? So the amplitude, well, that's going to be 15 because it's 15 distance from 20 to 15. The period, all right, so now that we know the amplitude is 15, we can try and find the period and the midline of this graph as well. So we see that the period is 60. So we also know now that the period is 60. Once we know that the period is 60, we then can find the frequency and all that stuff. That'll help us identify the actual function. The other part here that asks us to find is the midline. So the midline is 20. So although it didn't ask us to find it in this part, I'm going to find the frequency. So I know that P times B equals 2 pi. Remember, we could always remember that as peanut butter equals 2 pi. So we know that 60 times b equals 2 pi. If I divide both sides by 60, I see that the frequency is pi over 30. And I'll just leave that in terms of pi. So now that I know all of that, I can write the equation. So it says to use h and a function of t, so it would be h of t. It says that it has an amplitude of 15, but notice this is an upside down cosine curve. So it's going to start with negative 15. The negative reflects it over the midline. It's a cosine curve of pi over 30 times t plus the midline of 20. So now that I know the equation, which I'm just going to rewrite here, so h of t equals negative, what was it, 15 cosine of pi over 30 t plus 20. I'm now asking you to find out, after 1 minute and 40 seconds, what is Don Quixote fell straight down off the windmill? How far did he fall? So essentially, I'm asking you to find the height that he was on the windmill after a time of 1 minute and 40 seconds. Now, remember, this function, the time, is in seconds. So 1 minute and 40 seconds is 100 seconds. So if I plug that into my calculator, remember you want to be in radians for this. So if you're not in radians, it's going to actually give you a false answer. So you want to make sure of that. So check your mode. So if I type in my answer here, negative 15 cosine of pi over 30, watch your parentheses, times 100 plus 20, you get 27.5 feet. So that's how high he was after that amount of time, so therefore that's how much he fell to the ground. For number 2, it's another Ferris wheel question. I promise you won't see another Ferris wheel question after this lesson. I don't think, I hope. Actually, I shouldn't promise that. Maybe you will, maybe you won't, but I'm hoping that you won't. So it says a Ferris wheel is constructed such that a person gets on the wheel at its lowest point, so that's talking about like the 6 o'clock position on a circle, 5 feet above the ground. So I know the minimum value is going to be 5. It says it reaches a highest point of 130 feet above the ground. So this is not necessarily saying that this graph is going to go up 130 from 5. It's saying that the maximum value is 130. It then says the amount of time it takes to complete 1 full cycle is 8 minutes. So if I go out 8 minutes, I can make that 4 minutes, 2 minutes, and 6 minutes. And it says to sketch a cycle of the person's vertical position after rotation. So if I start at the minimum point on a circle, it then says that it rotates. It doesn't actually tell us what direction it rotates because it really doesn't matter. Because if I start here, the next possible location after a quarter turn would be halfway. Then I'd go up to the top, and I'd be at halfway again, and I'd be back at the bottom. So I'm starting here. After a quarter turn, I'm halfway. After a half turn, I'm all the way at the top. After another quarter turn, I'm halfway again. And then after a full rotation, I'm back where I started. The key here is figuring out what's this middle number. Now in class, all the ones that we've done so far have been pretty easy to figure out what the midline is just by kind of guessing and checking. If you haven't noticed, the easiest way to find the midline is to subtract the minimum and the maximum and divide by 2. If you do that, these harder ones to figure out wind up coming out to be not as bad, so 62.5 feet. If you want to check it, you could do 130 minus 62.5, which gives us 67.5. So the 62.5 here, that's actually your amplitude, right? So when I mark this on my graph, this should actually be 67.5. So because 62.5 is your amplitude, I know how far up I'm going to go from the middle. Now, how I found the 67.5 is I added the amplitude to the 5. So now that I know all of this, I can go through and write a function of this graph. So it says determine the sinusoidal function of this position. It asks us to use y and t. So that's easy. So we have y equals, it's another negative cosine curve. And we said it was 62.5 for the amplitude. Now, I don't know what the frequency is. I do know that the period is 8. So if I do 8 times the frequency equals 2 pi, I can divide both sides by 8, and I see the frequency is pi over 4. So I can put pi over 4 in there, plus that 67.5 midline. And that's your answer. Hopefully this video helps. Make sure that you're going back and just kind of retrying some of these questions if you didn't get them right after watching the video. All right. Next time I see you, I know this week is kind of chopped up because of midterms and finals and regents exams and all that jazz. The next time that I see you in class, you will receive a take-home quiz, which is kind of a review of everything that we've just learned in this lesson and in the next lesson of the course. Best of luck.